Hi, my name is Nathan Andrew, and this is my CHUMP RAM MUX address, accumulator, and control build. This build runs through control lines through astable mode or monostable mode, using a button to step. This step pulled together every major subsystem built earlier in this term: the RAM, multiplexer, address register, accumulator, and the AT28C16 control program and control EPROMs. The RAM is a 74LS189, which stores 4-bit data across 16 addresses. It uses active low data outputs, so the wiring had to be inverted through a NOT gate. The control lines for the chip select and wire enable are tied according to the function table, so the RAM performs predicted read and write operations during each instruction cycle. The 157 multiplexer selects between program supplied values and internal CHUMP data. Everything depends on the select and strobe pins connected to the control EPROM. A low strobe enables the MUX outputs, and the select bit chooses whether the CHUMP uses the program EPROM output or a value coming from internal buses. This chip is essential for changing between instructions, fetch, and data manipulation. The address register holds the memory address being accessed. The 74LS174 is a 6-bit latch, but CHUMP uses its lower 4-bit. On each rising edge of the clock, the register latches the address value generated by the control EPROM. This is what allows RAM to be read from or written to at the correct location. The accumulator is the heart of the CHUMP's arithmetic. The 74LS377 latches the ALU output on the rising clock edge whenever the G pin is enabled by the control EPROM. This storage mechanism is what lets instructions like load, add, subtract perform properly. While the accumulator's LEDs were always on during debugging, now they barely are on at all. So yeah. Now the control EPROM. This is the most important chip. It takes the opcode from the program EPROM and outputs it in an 8-bit control signal. Each bit drives a different thing. Bits 0 to 3 control the ALU's select S3 to S0. Bit 4 is the ALU mode. Bit 5 is the ALU carry in. Bit 6 enables the accumulator latch, and bit 7 writes the address register's D5 input, which then gets sent to the ALU. Overall, this stage took longer than any other part of the CHUMP by far. I've spent days trying to debug this program counter, wondering why the control outputs are not outputting what I'm burning on them. But yeah, I do think the problem does lean back to this control EPROM, because the program counter won't work if these outputs aren't working properly, which I don't think they are. So hopefully by the final CHUMP build, we will have a working full CHUMP alongside 2 more EPROMs powering a dual 7-segment display, as well as my own little addition to this CHUMP. Thank you very much for watching, and hope to see you guys soon.